again, it's me, Brian. This time we're talking about discount factors. In business we get money, well we hope we get money, and we get it usually over a period of time. Otherwise it's called a lottery, or lottery win. Look at this, I'm going to get £1,000 investment today, and then over the course of 4 years I'm going to make £350 one year, then 400, then 200, then 200, and if I add up my money coming in, take away my money going out, I make a lovely profit of £150. Now, that probably doesn't feel right to you. I hope it doesn't feel right to you. Actually, in business, you don't necessarily need to be a genius at mathematics. There's a feel for how these numbers work. And your feeling straight away probably is that £150 doesn't seem very much over a 4-year period on an investment of 1,000. Good, go to the top of class. That's a good start. Actually, it's even worse than that, though, because you remember when your grandparents talked to you about when they were young, when they were your age, they could go to the cinema for 5 pence and still have money, enough money to get a bus fare home, or whatever, that sort of thing. You know, I know, that's inflation. So actually, money in the future is not worth as much as it is today. What we today can buy for £1,000, in 4 years' time, we'll need more than £1,000 to buy it. So that kind of erodes these values. That takes away our 150 a little bit. But in addition to that, how about if I say to you, send me £100, and in 5 years' time, I'll send you £100 back. Hopefully at this point you're not reaching for your checkbook. Okay, that would be an insane thing to do because you don't know who I am. But even if you did know me, actually I'm quite a trustworthy fellow, but even if you did know me, it still would be a bit risky. So actually, we usually want a bit of a risk premium. If I'm lending somebody money, I want a little bit of an interest on it, a little bit of a risk premium to allow for the fact that they might not pay me back. So that's another point. So we've got inflation and we've got risk. In addition to that, we have what we call the liquidity preference, or if you like, the idea that I'd rather have my money now because I could do something else with it. So what I'm starting to get into now, if you think, for example, if I said to you, you've won the lottery, you've won £10 million, you'd probably be quite happy. But if I said to you, there's a little bit of an admin error though, which means you won't get your cheque today, you're going to have to wait 2 weeks, you'd probably be quite cross. But how strange is that? Because actually, you didn't have 10 million at all a minute ago, but now something about having to wait for 2 weeks makes you feel uncomfortable, annoyed, or what have you. Well, hopefully not, if you're a well-balanced individual, but I bet most people would feel a bit aggrieved by having to wait for 2 weeks. We like the money now. It's called liquidity preference theory. It's called a bird in the bush is worth, a bird in the hand is worth 2 in the bush. Slip that. So, we want our money now, and we like to have it early, because we can do something with it. Okay? What we would call in economics opportunity cost of money. If we had it now, I could use it for other opportunities. So there's 3 little things there that eat away at the value of these inflows. Inflation, risk, and this loss of opportunity. So I need something that will make those numbers smaller. Okay? I need to make them smaller. Well, as we saw in the last session when we talked about percentages and decimals, and I'm sure you could probably guess, if I was to multiply these numbers by a decimal, they get smaller, okay? Nice and easy. Now that decimal needs to be sort of worked out in some way. You couldn't randomly pick one from the air, although at times economics seems a bit like that. What we're going to do instead is use what's called a discount factor. Now, if you put that into Google, discount factor table, you will find loads of them. Nice and easy. Okay, so all of this has been worked out for you, or you can use an Excel spreadsheet and work it out for yourself. I'm obviously going to have to show you a couple of little bits of maths, but please, as I said, I'm showing you the maths because it makes it easier for my explanation, but actually, you, everybody else would look it up in a table. So, what am I going to do here? I'm going to need some way of discounting that £350, of making it smaller, making it reduced. What I'll need to do is to think about what this money is costing me. That's a whole other video, okay? And like I said, if I get some feedback from these, maybe I'll do that one for you as well. But there's a whole other video about how we work out what money costs, what we would call the cost of capital. But let's just say it's 10%. 10% is nice and easy, okay? So let's say it's 10%. What I want to do is to reduce this one by a proportion that's linked to the 10% over many years. It's not 10% this year, but 10% over many years. So what I'll do is I will divide it by, I'll multiply it by 1 divided by 1 plus 0.1. And do you remember in the last video, that's our 10%, that 0.1. That'll be the first year. Okay. The second year, I'm going to multiply by 1 divided by 1 plus 0.1 to the power of 2, because it's the second year. The third year, 1 divided by 1 plus 0.1 to the power of 3. And the fourth year, 1 to the plus up to the power of 4. Okay? So I've got 1 divided by 1.1, 1 divided by 1.1 to the power of 2, 1 divided by 1.1 to the power of 3, 1 divided by 1.1 to the power of 4 on a table. Forget what I've just done. If you Google it, you will find a table. What you're looking for is a table at 10%. The discount factor here I've used is 10%. It could be 12, it could be 15, it could be any number, but I'm using 10 just for convenience, 10%. Okay? If you were to do this maths or look it up on one of those tables, you'll see that you'll get values of 0.9, 0.9, 0.826, 0.751, and 0.683. Now, when I multiply this through, what we'll see immediately is that of course those values will diminish. Okay, so of course these values will become smaller. 350 times 0.909, okay, will actually produce for me 318. I'm going to put it here just for convenience. I appreciate that's a strange way of writing, but just for convenience, so it'll be nice and smack bang in the middle of the board, we can compare it. If I times 400 by 826, I'm going to get 331. If I times 200 by 751, I'm going to get 150. And if we times 200 by 0.683, I'm going to get 137. I will point out, I'm not doing this in my head, I've got it written on a piece of paper over there. If I now just tidy this up and remove these for you, I can get to what we're actually looking at here. And we can see that the 350 has been reduced to 318. But the one bit I'd like to point out to you is that both of these values are both £200. Year 3, 200 becomes 150. Year 4, 200 becomes 137. The further we go into the future, the more damaging, if you like, the discount factors are. If I add up these values, okay, we get to 936 coming in, £936 coming in. If I compare that with my original £1,000, what we see, of course, is that we've made a loss of £64. Okay, difference between this and this is actually minus 64. That's no good. Okay, we don't want to do this investment anymore. This investment doesn't actually increase our wealth, it reduces it. Although there's a positive cash flow coming in, it reduces our wealth. So, what we've learned from this is that this project cannot withstand a return of 10%. If we demand or require a return of 10%, this project will not provide that for us. It will actually reduce our wealth and not enhance it if we require a return of 10%. I expect you can probably guess that if I use 20% instead, it would be even worse. And if I use 5%, it might be better. What we'll look at in the next video is how I can work out exactly what percentage will turn these values into zero, into that balance point between the two. Because if 10% makes it minus 64, there must be another value that would make it balance, if you like. I'm not going to use the word break even, but it's going to balance. It's going to be neither a reduction in our wealth or an enhancement, but it will have met our needs, our return needs. Okay, so we will have got wealthier by 10%, but we won't have gone beyond that. It won't have added additional value. But of course, 10% return may be more than satisfactory. So, just to recap, these are our cash flows that we forecasted with our marketing department. We adjusted them then using a discount factor table. If you Google it, discount factor table, you'll see tables of values. Along the top will be written the percentages. Those are your costs of capital. Down the sides, your years. Just find one of those little boxes and multiply it by your forecasted value. It's as easy as that. We've gone a little bit further and shown you how you work out those values in terms of the calculation, but it's as easy as timesing two numbers together to get the discount factor and to get the discounted value. Really useful in business. This is part of what we call financial management, and we will go on to see some more bits and pieces around this. Like I said, if there's enough interest, I'll come back and do the cost of capital one for you, because actually working out what the 10% is in itself a whole art and a whole science in trying to work out whether it's 10% or 11% or which one you need to use. use. But we'll come back to that. So next session, we'll try and figure out the rate of return here. Okay, thank you.